Good day, Earth Science students. Welcome to Video Lecture Episode 12. Today we're continuing in Chapter 23, the Sun, Earth, Moon System, which is part of Unit 7, Astronomy. Last time we were talking, we mentioned about the spherical shape of the Earth. That's where we finished up, and we're just going to add some additional evidence to that, starting on slides 16, 17, and 18. Alright, on slide 16 it says, sailors also noticed changes in how the night sky looked. As they sailed north or south, the North Star moved higher or lower in the sky. So sailors were able to notice, just by looking up at the sky, that there was something different about the night sky. In other words, the North Star, which is called Polaris, they noticed it was either higher or lower based on whether they traveled north or south. Now, the best explanation was, in this, from what they had from the evidence, was that Earth was a sphere. Now, while that wasn't always common knowledge, today most people know that Earth is spherical. They also know all objects are attracted by gravity to the center of a spherical Earth. Now, to add to this, astronauts have clearly seen the spherical shape of Earth when they've been obviously outside the Earth and looked on it. Now, what they did notice is that there's a slight bulge at the equator and it's somewhat flattened at the poles, so it's not a perfect sphere, but it is spherical in shape, which is pretty cool to think that we have now the evidence to continue to just confirm what early people speculated. Now, let's just go ahead and integrate a little bit of life science in this just briefly. Suppose that Earth's rotation took twice as long as it does now. I would like you to predict how conditions such as global temperatures, work schedules, plant growth, and other factors might change under these circumstances. If you want, please leave those in the comments. I'd be curious to see what some of you think in this regard. Now let's move into another property of Earth, and that's rotation. Earth's axis is the imaginary vertical line around which Earth spins. This line cuts directly through the center of the Earth, so if you look on slide 20, I have a picture, an image to illustrate that for you. The poles are located at the north and south ends of Earth's axis. The spinning of Earth on its axis is called rotation, which causes day and night to occur. And if you look at slide 21, I just have some graphics to illustrate this a little bit more. So let's talk about how it works. Well, here's how it works. As Earth rotates, you can see the sun come into view at daybreak. Earth continues to spin, making it seem as if the sun moves across the sky until it sets at night. During night, your area of Earth has rotated so that it is on the opposite side as the sun, and because of this, the sun is no longer visible to you, and instead you see like a similar image like on slide 23, where you can see the stars in the night sky. Earth continues to rotate steadily, and eventually the sun comes into view again the next morning. One complete rotation takes about 24 hours, or, as we know it, 1 day. Now, here's a question, just think about it. The answer is obviously on the slide, but just think about it for a moment. How many rotations does Earth complete during 1 year? Well, it completes roughly about 365 rotations during its 1 year journey around the sun. Alright? Now let's get into another concept in connection with properties of the Earth, and that we're going to talk about the magnetic field, and we're going to have a physics integration along with this. Scientists hypothesize that the movement of material inside Earth's core, along with Earth's rotation, generates what we call a magnetic field. This magnetic field is much like that of a bar magnet. Now if you look on slide 26, I just have two images comparing a bar magnet and the planet Earth with its magnetic field as well. Earth has a north and a south magnetic pole, just as a bar magnet has opposite magnetic poles at each of its ends. When you sprinkle iron shavings over a bar magnet, the shavings align with the magnetic field of the magnet. You can see this illustrated on the image I have on slide 27, and this is something you can do as well. It's pretty cool. Actually, a really cool way to just illustrate this. You can just get these magnets fairly cheap and then get the iron fillings and do this, and it's cool. Now, as you can see in the figure, or the image that I have on slide 28, Earth's magnetic field is similar, almost as if Earth contained a giant bar magnet. Earth's magnetic field protects you from harmful solar radiation by trapping many charged particles from the sun, and the image that I have that illustrates this on slide 28 is very helpful for this, okay? So just take a look at that, make sure you just, take it in so you understand what we're talking about here. Now let's talk a little bit more about the magnetic axis. When you observe a compass needle pointing north, you are seeing evidence of Earth's magnetic field. Earth's magnetic axis, the line joining its north and south magnetic poles, does not align with its rotational axis. Just keep that in mind. So there's magnetic north and there's the other north, just in case if you've ever wondered why you hear two different types of north, okay? Now, continue our discussion with the magnetic axis. The magnetic axis is inclined at an angle of 11.5 degrees to the rotational axis. So keep that in mind. The magnetic axis is at an angle of 11.5 degrees, and that's not the same place as the rotational axis. If you look on slide 30, you see a visualization showing the magnetic North Pole versus the geographic North Pole, so there is a little bit of a comparison. Now, if you followed a compass needle, you would end up at the magnetic North Pole rather than the rotational North Pole, which is kind of interesting to think about. Well, let's go ahead and finish our discussion just briefly, continuing talking about the magnetic axis a little bit more. The location of the magnetic poles have been shown to change slowly over time. Curious, maybe you didn't know that. The magnetic poles move around the rotational, or geographic poles, in an irregular way, and so hence there's that changing over time. Alright, ladies and gentlemen, this concludes our discussion on properties of the Earth. I do hope this has been helpful. If you have any questions, you can leave them in the comments below. Reach out to me, sending me emails and messages. Have a nice day, and I do hope this lecture has been helpful. Goodbye.